I'm Hugh Collingbourne, Director of Technology with SapphireSteel software. In this tutorial, I'll be continuing development of a simple adventure game to explain some features of object orientation in ActionScript 3. I'll be using the Amethyst IDE for the Adobe Flash platform, but you can use a different editor or IDE if you prefer. The source code for these tutorials is available for download from the SapphireSteel software website. This is the first of two tutorials based on project 05_OOP_3. In the previous version of this program, each room object contained 5 strings. One was the name of the room itself, and the others were the names of the adjoining rooms to the north, south, east and west. I wrote a routine, show exits, that examined a single room object and then displayed the adjoining rooms. Now, it would be relatively simple to adapt this so that when the user wants to move north, say, I obtain the name associated with the north direction, the variable n, of the current room, and then search for the room object with that name. In its simplest form, rooms might be stored in an array, and when the player moves from room 1 to room 2, a global variable is assigned the value of the matching array index. That works okay, but it's kind of inelegant. And with an object-oriented language such as ActionScript, it really isn't necessary, because each object can store actual references to other objects. Let's see how this is done. First, I've rewritten the room class so that all its variables, the variables indicating rooms at the exits in the 4 compass directions, refer to room objects. But there's a subtle problem here. Think about it. When I create a new room, the room constructor is called. However, at this point, I can't assign room objects to the 4 direction variables because, I can't be sure that the room objects to which these variables refer have been created yet. For example, when I create room 1, I can't assign room 2 to its northern exit because room 2 hasn't been created. My solution to this problem is to assign null values to the 4 direction variables when I create each new object. And then later on, when I'm sure that all the rooms in my game have been created, I wire up their exits to other rooms in this init method. Now, first I create the rooms. And that's done here, and then I initialize them by calling the init method. And that's down here. And I pass other rooms as arguments for the north, south, west and east directions. And when there's no exit, I pass a variable called noExit, which is in fact just a null value. Now the cave argument here is a reference to the cave room, which I created here, and which I initialized here. And that's the same for all the other rooms as well. Now let me turn to the user interface. In this game, text output will be displayed in this text area. And the player will move around by clicking buttons which pass a direction, a string, such as n, to the move to method. And you can see that's been wired up to the click event here. In Amethyst, I can go straight to the associated method by double-clicking one of the buttons. So I'll double-click the north button, and here I'm at the move to method. The string indicating the direction arrives as the argument named a direction. The here variable, which once again is a room object, stores a reference to the player's current location. The case statement executes a different bit of code according to the value of the incoming argument. If this is n for north, it sets a room variable, new room, to refer to the room object, if there is one, at the n direction of the current room. Here, that's here.n. Finally, the here variable is updated to this new location. But what exactly are these direction things, n, s, w and e? They may look like public variables of the room class, but they aren't. They're properties. Now I'll explain what these are and how they work in my next tutorial. To download the source code for this and the other tutorials in this series, go to www.sapphiresteel.com.